Our first speaker who is with us today is Rosa Schneider, who's an environmental scientist with the California State Parks. Hi, Rosa.
Hi.
And Rosa was with us as a staff member with Golden Gate Parks Conservancy, working with the OneTam initiative pretty much from the beginning. And I invited her here today to do this lead presentation on Climate Change 101, what is happening here, because Rosa was also a middle school teacher. And she can present information with a clarity and a directness and a simplicity that I think this moment calls for. So with that, I'd like to turn you over to Rosa. Thank you.
Thanks, Janet. Can you see my first slide?
Yes, I can.
Okay, thanks. I'll get started. So thanks for the welcome. Thanks for that lovely introduction. Like Janet said, climate change can be a heavy topic, especially this year, especially this week. But for this morning and the rest of the month, we have the opportunity to learn from people working on it from all angles and to think about where we fit in at work, at school, in our communities, or at the political level. And also I want to second Janet's welcome to the students today. You're at a time in your life when learning is a priority, and I just want to say you don't need to be a scientist to work on this issue. There's room for everybody and we need everybody. So this morning we're going to take a step back and look at the bigger picture of basic climate change science. I'll be talking about predicted changes for our region in terms of temperature, drought, extreme precipitation, sea level rise, and fire regimes, and kind of how it relates to parks and resource management in Marin and in the region. And then the speakers following me today are going to broaden the conversation, like Janet said, beyond what we typically talk about at science summits. So for starters, let's talk about the basic mechanism of climate change. My favorite metaphor, you can find it on the resources page on the summit website, but it is from Noki, and it's the metaphor of the heat trapping blanket. So basically when we burn fossil fuels for energy, we're adding more and more carbon dioxide and other heat trapping gases into our atmosphere, and that buildup acts like a blanket. It traps heat around the earth and it disrupts our climate. Surprisingly, if you look online, there are really no pictures or diagrams of the atmosphere that show it to scale. It's much more like the skin of an apple on the right there. So the atmosphere is not just this big empty space waiting for us to put carbon dioxide and whatever else we want into it. It's small compared to our Earth, so what we do to it really matters. So how does heating up the air and oceans, how does this disrupt the climate? So we have increasing temperatures, which I'll talk about shortly, but it's more than that. Climate change, it doesn't heat up all parts of the Earth at the same rate. And so this affects big patterns like the global winds and the jet stream. And this example here is for the jet stream. It's a fast moving wind, and it drives a lot of the weather at our latitude, so in North America. And because the Arctic is heating up faster than the rest of the planet, the differences in temperature that drive the jet stream, it's reduced. So the jet stream is slowing down. And one thing that this can do is it causes periods of stormy weather, so that's in the blue, or zones of hot and dry weather, that's in the red, to kind of just get stuck and sit on regions for longer than they normally would. So I'll start off with temperature. We've had some pretty intense heat waves lately, so we know and we're living that temperatures are already increasing. Overall, from 1950 to 2005, the Bay Area's average annual maximum temperature increased by 1.7 degrees Fahrenheit, so almost 1 degree Celsius. A lot of these diagrams come from the California Climate Assessment. That's also on the resources page. There's been a lot of very detailed work done, and I encourage you to check out those reports. So there's also different scenarios for climate change. Today I'll be mentioning two of them. There's the RCP 4.5, and that's kind of like if we really get our act together and reduce our emissions, this is what's predicted. The RCP 8.5, that's a high emissions trajectory, and unfortunately we're kind of following that for now. But in terms of temperature, by the middle of the century, if we reduce emissions a lot, we will see annual mean warming of about 3 degrees Fahrenheit. The other trajectory, the higher trajectory, is more like 5 degrees. And then by the end of the century, we will be looking at 4 degrees under the lower trajectory and about 7 degrees of annual warming under the higher trajectory. So it's not just the average temperature that matters. These heat waves can really stress out humans and our health, and also other living things and ecosystems. So we're looking at the change in the hottest day of the year. And under the 4.5 scenario, that would increase by about 4 degrees on the coast, up to about 6.5 degrees Fahrenheit inland. And under the higher scenario, we'd be looking at 6 degrees Fahrenheit on the coast and 10 degrees Fahrenheit inland, and that's by the end of the century, so that's quite a bit. So what do these warmer temperatures mean for other species and ecosystems? Temperature affects the metabolism and functioning of all living things. It's one of the major factors that affects where different species can live and how kind of plant communities are structured. And it's not only about the warm temperatures, it's also about the low temperatures, which are also increasing. So cold is important for dormancy in plants and for hibernation in animals, among other things. The one example I'll give quickly comes from the Sierra. There was a study early in the 1900s, a mammal survey by Grinnell, and that was recently repeated about 10 years ago. And the scientists found that about half of the small mammals that they studied moved up in elevation a few hundred feet. So these species ranges are already changing, and that's leading to new kind of different groups of species living together. And we'll hear a lot more about species towards the end of the month, but just know that each of these changes, it affects individual species, but it also affects species as a whole, and it affects how our ecosystems function. And those are the ecosystems that support our air and our water and everything else. Okay, let's talk about drought and extreme precipitation and why we're expecting to see more of both of them. On the left, that photo is from Stinson Beach just over 2 years ago. We got 8 inches of rain in less than a day, and the creek, Eskew Creek, jumped its banks and decided to go through the parking lot. So this was kind of an extreme precipitation event with a really visible result for us here in the region. The photo on the right is not from the Bay Area, but it's also pretty striking, Lake Oroville during the historic drought. So both drought and extreme precipitation, they're kind of two sides of the same coin. They're affected by climate change in related ways. So let's take a look. So not long ago, as I mentioned, we experienced the record warmth from 2012 to 2016 alongside many dry years. So this was the most extreme drought since record keeping started in 1895. And it wasn't caused by climate change alone, but there's something called attribution science, and that's a field of modeling where scientists are able to give an estimate of how much climate change is contributing to these extreme events. And for this one, the estimates came in at this extreme event was intensified between 8 and 27% due to climate change. So yeah, it's hard to put a number on it, but we do have a range. So with increasing temperatures, more water transpires out of plants and leaves the soil, and more water evaporates from water bodies. So as it gets warmer, overall our ecosystems are getting drier. And as I mentioned earlier, the large-scale wind patterns are making it more common for these areas of dry and hot air to get stuck on our region and on other regions. So the droughts that we do have can be longer. And then finally, the warming temperatures also affect how much precipitation is coming down as rain versus snow. So we're starting to see less snow and earlier snow melt from the Sierra and other areas of the state. And so that creates more of a drought for humans and a drought for our crops. So the water is not coming down at the same time that we want to be using it. So what about rainfall? If you've lived in California for a while, you know that our rainfall is highly variable. So we have wet years, we have dry years, and this means that the climate change models, they're not finding a strong signal about whether it will rain more or less in the future, but all of the models agree that we're going to have more extreme precipitation events. And that is because the ocean, the sea surface is heating up also. It's not just the air heating up. So more water is going into the atmosphere. The warmer air holds more water. And then, as I mentioned earlier, these large-scale wind patterns are causing storm zones to kind of stall out and get stuck in certain areas. And sometimes that's where California is. In this image, the colors are showing a long, narrow band of moisture that's headed for the West Coast. And we call that an atmospheric river because it can hold quite a bit of water, like as much as a river. Some people call them Pineapple Express storms. So what is expected? We're going to be looking at more years where we have these atmospheric rivers, more of these rivers each year, a longer season for these rivers, and more water in those storms. So it's not going to be every year, but overall, more of our rain will be coming in these intense storms. Under the high emission scenario, a storm that now happens every 20 years would, scientists think it'll happen every 7 years. And a storm that is now once in every 200 years is predicted to be once in every 40 or 50 years by the end of the century. And that, that has a lot of implications for public health and public safety with flooding. We'll talk about sea level rise later. And it also has ecological implications, which I'll talk about in a little bit. So we don't know if precipitation is going to go up or down, but because it's getting warmer, ecosystems will be drying out. And this leads to something called a climatic water deficit in plants. It's a measure of plant stress, and it's the difference between the water that plants could potentially use compared to what they actually are getting from the soil. So these maps show different climatic water deficit projections under different scenarios. So a warmer and wetter future, a hotter and drier future, lower emissions, higher emissions. But no matter the scenario, in almost all scenarios, we're looking at drought-stressed vegetation. So the green, if you look at the orange, kind of dark orange color, so a climatic water deficit of 200 millimeters, that means that's about 8 inches of rain a year that the plants are stressed by, and that's quite a bit. So to sum it up, we're looking at more year-to-year variability, so years with a lot of rain, maybe periods of several years with very low precipitation. And from a parks perspective, we know that our plants and animals, they're adapted to seasonal drought in our Mediterranean climate. So a lot of plants around here go dormant in the summer or during the dry season. A lot of animals kind of lay low or adjust their life cycles to meet that dry season. But more frequent droughts and more severe droughts that's a different story. The photo on the left is from the Sierra Nevada, where there were about 130 million trees that died during the recent historic drought. And for wildlife, during periods of drought, those kind of aquatic habitats, so those seeps and springs and ponds, they become more important, and the animals can concentrate there, so that can lead to like more disease, more predation, and animals can also just have mortality from drought and heat. So in the parks world, there's always been a focus on wetland habitats because they're so important, but climate change is just making that even more so. So the seeps, the springs, the creeks, the waterways, They're becoming an increased focus of monitoring and restoration. Many of you who love Mount Tam are probably familiar with the Redwood Creek Trail. And earlier this summer, the realignment project kicked off. So that's the trails moving up out of the floodplain. And this is kind of setting the stage for a future floodplain restoration project, which will allow reconnecting the creek to the floodplain. So during high flow years, that'll allow more water to sink into the ground to be available during drier years. So this is just one small example of some of the things that parks are doing to work on drought and extreme flooding. Okay, sea level rise. This photo comes from China Camp State Park. It's in unincorporated San Rafael. North San Pedro Road runs right through it, and it's a very popular photography spot during high tides because it's already low lying, and we're looking at what to do with this area in the future. I'll just say a few things about what's driving sea level rise. So most people know about the ice caps and the glaciers melting, adding more water to the oceans, but because the ocean temperatures are increasing, that is causing thermal expansion. So the warmer water takes up more space than the colder water, and that's contributing to sea level rise. In some places, land subsidence, so land sinking and plate tectonics are contributing to sea level rise, but that's not so much in our region. So currently, predictions for sea level rise by the end of the century in the Bay Area are between 2.5 and 5 feet. This map shows where the water level would reach with 5 feet of sea level rise without any adaptation responses, so without any changes to our shoreline. And there's currently over 200 feet of sea level rise contained in ice, but let's take it one step at a time. One thing that's kind of unfortunate about the way we built our society is that a lot of our infrastructure, like our roads, our wastewater treatment plants, our power substations, they're along the bay shoreline. So we're going to face some challenges there. And then in the Bay Area and many regions, a lot of the communities that live close to the bay are lower income and more vulnerable to flooding. So what about the shoreline itself? San Francisco Bay, we've lost about 90% of our original tidal wetlands since the 1800s. But on the flip side, we have 90% of the state's remaining wetlands. These wetlands protect the shoreline, they filter pollution, they provide habitat. And with enough sediment coming in from the watersheds and from the bay itself, we expect some of these marshes to keep up with sea level rise, at least in the short term. And there is a huge effort to get more shoreline areas that are either salt ponds or diked agricultural lands restored to tidal marsh as soon as possible. Because if we can connect those areas to the bay now, that will take much less sediment and much less effort than trying to connect them in the future. This is another photo of our famous road in China Camp, and you're going to hear a lot more, I think, in 2 weeks about sea level rise and adaptation efforts. But with the San Francisco Bay NER, they've led an effort with us and Marin County to consider different alternatives for what to do about that road and the amazing marsh that it passes through. So in 2019, there was a series of workshops to kind of evaluate different alternatives along with the community and pick a few to move forward with. So this is just one road in the whole Bay Area. So we've definitely got our work cut out for us as far as adaptation efforts. Okay, the topic that is on a lot of our minds lately, fire regimes. So we're currently living through our state's most extensive fire season. And we've had 3 million acres burn already this year. That's like 25 times the acres that burned last year. And it's becoming more widely known that climate change is a contributing factor here. We're seeing regions like the Sonoma Valley and the Mayacamas Mountains. They're experiencing large fires, like 3 out of the last 4 seasons. Just this week, we have wildfires in 4 of my district's state parks. And it's just, it's just really heartbreaking to see friends and family evacuating, losing their homes, and then everybody else, suffering with the smoke. So I just want to acknowledge that before we get into kind of the science behind it. This diagram shows fire behavior triangles. There's a fire behavior triangle and then moving on up to a fire regime triangle. And I think it's important to take a step back and think about, what components make up a fire and then how the climate fits in. So on the left, that triangle with flame in the center, that's like if you're trying to build a campfire or you're trying to build a fire in your fireplace, although who would ever want to do that anymore? So you need fuel, you need something to burn, you need oxygen, you need a flame, you need a heat, and then you'll get a flame. And so that's just on the order of seconds. Once you have a fire going, it moves up to the middle triangle, so on the order of days. And this is what we're kind of dealing with right now in Sonoma and Napa counties. So we have fire weather, we have the topography, a lot of steep terrain that's feeding that, contributing to that fire, and then the fuel, everything that's burning. And then moving up the time scale to decades and the space scale to kind of the hundreds of kilometers squared, that's your fire regime. So those are the patterns of fire that we see over time. And this is where we're seeing the signal of climate change. A recent paper came out that talked about how the fire weather, the extreme fire weather days are, they look like they're doubling with climate change. And that's, the warmer temperatures dry out the vegetation, the warmer temperatures lengthen the number of days per year when it's likely to have a fire. And then also in terms of vegetation, the history of fire suppression in our state isn't doing us any favors. So this photo was from earlier this month, or this image from NASA showing the smoke from many of those lightning-caused fires and fires that came with the red flag weather shortly after. So if we compare wildfire frequency, even from 1970 to the early 2000s, we've seen that large fires have increased by about 400%. The wildfire season, as I said, is getting longer by a few months. The individual fires are lasting longer. And so all of this is predicted to continue with climate change, and that is heavy. So what does this mean for parks? We know that everyone knows that out of control fires are really destructive to our society. Our California biodiversity, it evolved with fire. So many different Native American tribes, they used fire, they continue to use fire to promote certain species, populations, habitat, landscapes. And some native plants need fire and smoke and heat to germinate. One thing that's often overlooked in the news is that fire severity really varies across the landscape. So Sugarloaf Ridge State Park, it's having a fire now. It had a fire 3 years ago. And this map just shows the fire severity throughout the park. So some areas in the red burned at high severity, some in the blue burned at low severity, and this, this affects kind of which vegetation grows back and how quickly it goes back. But generally, a fire, fires are not as destructive to the land as they are to people. So for decades, state parks has been using prescribed fire and other practices like succession management, so removing brush that's invading grasslands or removing dug fir that's invading oak woodlands, basically to promote biodiversity. But these practices also help reduce fuels on the landscape. And we're seeing a lot more interest in prescribed burning as people become more aware of climate change. One study came out that said that prescribed burning can reduce carbon dioxide emissions by 60% compared to large wildfires. But it's really important to understand that prescribed fire and other practices, they're not going to prevent the large, like extreme wind-driven fires that we're seeing now, but they can, they can help with other fires in other situations. A few other things that that those of us in parks work on with fire, we do a lot of work with the firefighters to try to minimize the damage of the firefighting on natural resources. So this middle photo shows a bulldozer line up on Mount St. Helena in Robert Louis Stevenson State Park. So we work with the firefighters to try to, as much as possible, have their efforts not damage the resources or after to try to rehabilitate the areas. And then we also do a lot of monitoring, so seeing what grows back after a fire, how the ecology changes. So to end on a hopeful note, we have seen a lot of interest from the public in learning about fire ecology lately. People are becoming more kind of accepting of fire and learning about it. This photo was from a OneTam volunteer event on Mount Tam, where we taught people about fire ecology and then actually had them remove coyote brush from grassland, so in the absence of wildfire. And I've seen in my work that people from many backgrounds are interested in this issue. So some people from a historical perspective or public safety, public health, ecological. So this is one area where I have a lot of hope. And I think next week we will hear a lot more about fires and forest ecology. And I just want to acknowledge the people who helped develop these ideas and make this presentation. When I was at the Parks Conservancy, I led my interns. We did a literature review about climate change impacts to parks. So I want to acknowledge all of them, and I want to acknowledge Janet for encouraging me to present this work.
Thank you, Rosa. That was terrific. And per the request of a couple people have been texting me and asking me to present a series of emotional support animals after some of the heavier content today. So if folks would like to ask Rosa a question, please put it in the chat. And I also understand that, so first on the Nearpod problem, I think we've got it fixed for when we do the next one. Thank you everyone for letting us know. And for folk, I understand some folks are having trouble logging in to the symposium in full. If you know of someone who is having trouble logging in, I am sharing in the chat an email address of someone who you can contact, and they can try to help with that login problem. Okay, are we ready for the Q&A, Rosa? The first question that I got was from someone who asked, how is it that you manage to persevere and show up at work every day knowing everything that you know right now? How do you maintain hope and positivity?
I actually feel lucky that this is my job because I get to work on this every day, and I can put all of my energy into it. And it's not something that's just like at the end of the day reading the news. So, I'm very encouraged by my professional community and all the dialogue and all the partnerships and all the research that's going on in the Bay Area. So for me, it's like, I'm not happy about it, but I feel lucky that there are so many opportunities to work on this now, and that the public is getting more aware and more receptive.
Great, thanks, Rosa. Okay, the next question we have is, with an increase in fire frequency and intensity, we're wondering about the conversion of plant communities and ecosystems. What are the predictions for our area, and where can we learn more?
Okay, can I share my screen again if I want to show a slide? I'm going to see if I can do that. Okay, can you see that? No. All right, so there's been a lot of kind of modeling work done on what plant communities are expected to look like in the future. The slide I showed for a climatic water deficit kind of sums it up, like everything's getting dried out. So fire is one of those things where that can kind of kick with a high severity fire that could, change something from a forest to a shrubland. But yeah, so we're overall expecting, more shrublands compared to forests, but a lot of it depends on precipitation and on like the specific region where you are. So there's this idea of microclimates or climate refugia. So maybe some areas will stay foggy longer than others, but basically we see vegetation types shifting to higher elevation to kind of match the climate, higher elevation and northward. But that's a very broad answer. And I'll add some resources to the webpage if people want to learn more about plant community change.
Great, thank you. So someone asks, the fire footprint from the last 5 years now covers so much of Napa and Sonoma. A huge percentage of these lands have recently burned. Do you have any sense that these areas might now be safer?
I wish. So with a low severity fire, which a lot of this is, you can see the vegetation, the same vegetation type regrowing the next year. With a high severity fire, you might see Doug fir dying, being replaced by shrubs or grass, but we do get rain again, stuff does grow back. So you might see a different amount of fuels on the landscape, but it's, aside from paving everything over, we're not gonna, it's not gonna fireproof these areas, but I would expect it to change the behavior of smaller fires. And, there are small fires all the time, but it's just, you don't hear about fire in the news unless it's a really awful fire. So, the fires that disrupt our lives, that's on the extreme end. But I think the fuel reduction and the change that we're seeing, that could affect fire behavior for smaller fires. Same goes for our forest management practices.
Okay, unfortunately, we don't have time for any more questions. But Rosa has generously offered to host a 1-hour Q&A on climate change next week, and you'll be able to register for it through our website, and I'll provide some more information about it next week. At the end of today. And again, Rosa, I'd like to thank you. That was just a wealth of information. It was really amazing. So, and with that, I think I'm going to move on and introduce